Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Ready for today's lesson. It's the last lesson of chapter 1, which is primarily review, right? We're going to kind of build on what we were working on in the previous lesson where we were looking at proportional relationships. And now we're going to actually solve some problems that involve proportional relationships. Proportional relationships can be identified in both tables and graphs. In the last lesson, you also used both of these representations to make predictions about proportional situations. Today, you will continue to develop strategies for solving proportional situations using an equation. All right, so here's the situation. Kenny can make 7 origami cranes in 10 minutes. You can see on the table how that piece of information is here, and it kind of looks like it's proportional, right? Because you know, if you spend no time making cranes, you're not going to make any cranes. And if you go in the other direction, if you don't make any cranes, no time will be spent creating them. And so we're assuming there's going to be like a constant rate, right? For every 7 cranes, it takes 10 minutes. Okay, so we read the story about the girl who made 1,505 cranes. So he was curious how long that would take if he were to do it, if it was possible to continue doing it without stopping, right? No restroom breaks, no going to sleep, no eating, nothing. Just going straight through. How long would that take? So our job is to kind of complete this table and figure out what number goes here. Okay, and these questions that are being asked, we're actually going to not do it right now. We're going to go through a bit of a process and then declare the answer within that process. Instead of solving the problem using a table or graph, Kenny represented the 7 cranes in 10 minutes as this ratio, right? So the answer to this, if we wanted to find a unit rate, we could figure out how many minutes it takes per crane. But that's not what we're going for here. We're just going to go straight to the number of minutes it takes to make 1,500 cranes. So this is the proportional reasoning that you would use to try and figure out the answer to this question if you weren't going to go through a unit rate and just figure out the exact number of minutes for that number of cranes. Now the question here is directing us to use 2 different strategies to find the missing value in the equivalent ratio. So last year, you may recall looking for a giant 1. You may recall us using a unit rate. You might recall us using cross multiplication. Go ahead and see if you can figure out what the answer is. Use any strategy that you want, okay? I'm not going to declare the answer yet. You go ahead and pause it and see if you can come up with the answer. And then we're going to talk about 3 of the more popular strategies that are used, actually 3 of the 4, because I don't think we're going to really address unit rates in this particular activity. But we're going to try 3 different strategies that you can use with this proportion right here. So go ahead and figure out what you think is the answer, and then unpause and join us. And then we'll see if what we get for our answer from using some different processes matches your answer. You might even find that one of these strategies that we're going to use on the next few pages might be the strategy that you used. Okay, so one strategy that I talked about is the giant 1. That is a great strategy if you've got some friendly numbers here. If you can figure out what number you multiply times 7 to give you 1,505, that number can be multiplied on the top and on the bottom. And in order to do that, you kind of have to think in terms of your multiplication fact family. 7 times something is 1,505. Therefore, 1,505 divided by 7 will tell you what that something is. Go ahead and pause the video, see if you can figure out what that multiplier needs to be, and I'm going to pause as well. All right, did you figure out what the multiplier is? Well, here's the work that you can show. I'm assuming you probably used a calculator, but I'll go ahead and show the division. What do you multiply times 7 to give you 1,505? Well, let's work through the division algorithm. 7 goes in 15 twice, that's 14. Gives you a remainder of 1. You bring down the 0, 7 goes into 10 one time. That gives you 7. So you subtract, you get 3, bring down the next digit. How many times does 7 go into 35? That is 215 times. So that means that we've got ourselves a multiplier here, where we're going to multiply this times 215, and our giant 1 requires us to multiply the 10 times 215. And so what we end up getting, and hopefully this is your answer, is it would take 2,150 minutes of working non-stop at that rate of speed, 10 minutes for every 7 cranes, in order to make the 1,505 cranes. So that's using the giant 1. We spent a lot of time using the giant 1 last year. And if you're new to our school this year and you've never heard of the giant 1 is what you get when you write a fraction where the numerator and denominator are exactly the same thing. And this particular program calls it the giant 1 because whenever you multiply anything times 1, it's always equal to itself. So if I take the fraction 1 over 2 and I multiply it times 1, I'm going to get 1/2, correct? But if I decide, okay, I want to just change the ratio, so I'll multiply that times, say, 5 over 5, that's a giant 1. It's going to be, this fraction is going to be equal to that fraction, so you get 5 over 10. These two are equivalent fractions. Okay, so that's what's happening here is we're creating equivalent fractions. When you're dealing with a proportional and proportional or proportion and proportional reasoning, this ratio has to be equal to that one. And the only way to get there is by multiplying the numerator and denominator times the same number. So whenever we refer to the giant 1, we're talking about this idea here. All right, now this is probably the least common strategy that people use. But you've done stuff like this before. Remember, whatever you do to one side of the equation, do the same thing to the other. Well, we've got an x here that's being divided by 1,505. So if I want to undo that, I could multiply both sides of the equation times 1,505. That essentially cancels out that division here, leaving you with only the x. But now you've got to multiply 1,505 times 10 over 7. So remember, you're multiplying numerator times numerator and denominator times denominator. Go ahead and work through that process to see what you get. In fact, you probably already got your answer, but go ahead and copy this down, show this process, and then unpause it when you've got all of your work shown and you've got an answer, hopefully matches what we had on the previous problem. All right, so what do we have here? When you multiply 1,505 times 10, you get 15,050. And then you'd have the 7 in the denominator. So x is equal to 15,000. I should probably put in a comma there, just to be, yes, there we go. X is equal to 15,050 divided by 7. So we work through the process, and you see, oh yeah, we get the same answer, right? Instead of it being 1,505 divided by 7 is 215, it's 15,050 divided by 7, which is 2,150. So we get the exact same answer, okay? So why are both sides being multiplied times 1,505? Because of the property of equality that says whatever you do to one side of the equation, you do the exact same thing to the other. We chose to multiply the right side times 1,505 to cancel out this denominator, essentially turning them into a giant 1. But you can't just multiply the right side without also multiplying the left side times the same thing. Okay, so that is a strategy that works here. Probably the least favorite strategy that students use over the years, but it still works. If you like it, use it. Now for fraction busters. This is also known as cross multiplication. So what is essentially happening here is, and we'll work more on this a little bit later in the year, the idea of fraction busters. In order to rewrite this equation so it doesn't have any denominators, we need to multiply both sides times the same number. Well, if I multiply this side times 7, it'll cancel out the 7, but it won't cancel out the 1,500. And if I multiply this side times, and that's 1,505. If I multiply both sides times 1,505, it'll cancel out this 1,505, but it won't cancel out the 7. So essentially what we have to do is multiply both sides times both the 7 and the 1505. Is this one will cancel out the 7, and this guy cancels out the 1505, leaving you with 10 times 1505 and 7 times x, what we have here. Now, what I have found is it works much easier if you just picture it like this. You just think about the coat of arms cross multiplication. Eventually, what's going to happen is the 1500 cancels out on one side, so you're left with 7 times x. So you multiply the 7 times the x, and then the 7 is going to get canceled over on this side, leaving you with the 10 times the 1505. So that directly becomes this, which becomes this, which you solve by dividing each side by 7, and then you end up with the exact same ratio, right? This right here is a giant 1 that cancels out, leaving you with 15,050 divided by 7, just like we had up here. So all of these are somewhat related to each other. The strategies that you would use, all of them work. They all give you the correct answer, provided you do your calculations correctly. And I highly recommend you use your calculators to do this work. As we start getting into more detailed problem solving, I'm not as concerned with you showing that you know how to do the division algorithm like I did there. We can use our calculators. Now, if I were assessing you on your ability to divide, I would say don't use your calculator, but I'm assessing you on your ability to do proportional reasoning. So let's have our calculator be our tool for this problem. All right, so now we've got all these different strategies. Let's start using them. And typically I'm going to say, use whatever strategy you like best. But in a few problems where I want you to practice it and just give it a try, let's go ahead and use the strategy that they tell us to use, okay? So here's problem A. When he was little, Miguel could not sleep without his Captain Terrific action figure. It looked so lifelike because it was a perfect scale model. The actor who played Captain Terrific on television is 216, wow, that's tall, 216 centimeters tall. Miguel's doll is 10 centimeters tall. If the doll's neck is 93/100 of a centimeter long, then how long is the actor's neck in real life? So use undoing division method here. So basically, remember, go back and look at the work we did. In this case, 216 over 10 is equal to x divided by 93/100. So if I want to cancel out that division, I will multiply each side times 93/100 to cancel that out, and then solve the resulting ratio division problem that we've got here. Go ahead and pause, work through that process, and see if your answer is the same as the one that I'm going to declare. All right, let's see what you got. First of all, we would want to multiply each side times 93/100. That will cancel out the 93/100 here, just leave us with our 1x. But on this side, we're going to have to multiply 93/100 times 216 before we divide by 10. So what is the product of 93/100 and 216? It is 288 hundredths. Now we're going to take that number and divide it by 10, which would result in us just moving the decimal one place to the left. And you should have gotten something around 20.1. So that's the exact answer, but let's round it to the nearest tenth. So it looks like that action figure's neck, the guy who plays it in real life, would be 20 1/10 of a centimeter, or 20 centimeters and 1 millimeter. Okay, so that's the undoing division process for getting to the answer. Here's a different one. They want us to use fraction busters, which, remember, is the same as cross multiplication. Okay, so let's read through this situation. The Northwood School Math Club is having a tamale sale. The school has 1,600 students, but the club members are not sure how many tamales to make. One day during lunch, the club asked random students if they would buy a tamale. They found that 15 out of the 80 students that they surveyed said yes, they would like to buy a tamale. So, assuming that this is a properly randomized survey of the student population, they set up this ratio. If 15 out of every 80 students we survey will likely buy a tamale, how many total students out of the 1,600 would we expect to do it? Now, honestly, this one sets up nicely for the giant one because you see 8 goes into 16 twice. So I think if you multiply 80 times 20, that's going to give you the answer. But they don't want us using the giant one here. They want us using fraction busters. So go ahead and pause, set up that ratio. Go ahead and do your cross multiplication and see what x is equal to. All right, let's see if you got the same answer that I got. First of all, we're going to start with this. Now we are going to cross multiply, so we're going to get 80x is equal to 1,600 times 15, and 15 times 1,600 is 24,000. Why am I forgetting to put in my commas here? And so now we're going to take and divide both sides by 80, and what is 24 divided by 8? That's 3, correct? So 24,000 divided by 80 ends up giving us an answer of 300 tamales. So I'm going to just check because this seemed like it was pretty easy to do, right? If we had multiplied, let's put this on the left-hand side. If we had multiplied 80 times 20, that would give us 1,600, correct? So is 20 times 15 300? It is. So we've done it two different ways, got the exact same answer both ways, which proves that this works, proves that that works, okay? So yeah, that's the fraction busters or cross multiplication. All right, Elsie is starting a recycling club at her school and hopes to use the money to she earns from recycling cans to buy recycling bins for the school. Elsie first needs to figure out how much the cans can be collected at her school weigh. So she starts weighing cans in a recycling bin at home, and she finds that 50 cans weigh 0.8 of a kilogram. So here's the ratio: 50 cans over 8 kilograms. The next day, Elsie counts the cans at school and finds that her fellow students throw away 1,240 cans. So use this ratio, and you're allowed to use any method of your choice, okay? Any strategy that you'd like to use here to solve for x. How much will 1,240 cans weigh? Okay. Let's pause. Sorry, preemptive pause. When you've got your answer, unpause, and we'll see if you get the same answer as me. Okay, so what method did you use? Does 50 go nicely into 1,240? If it did, you could use your giant one. And if you chose to use a giant one, 1,240 divided by 50, you get 24.8. So if you multiply 24.8 times 0.8, you would find your answer using the giant one. In this case, using division doesn't really work very nicely because that's a little bit complicated. Now, there is a little trick. If you really love doing it that way, I don't know if you realize that you can do this, but you could actually change and reverse these. You put your x on the top and your 1,240, and now if you multiply both sides times 1,240, you would get a number divided by 50, which would give you your answer. I'm doubting anyone chose to do that. I actually decided to go with cross multiplication. I decided to multiply 8 times 1,000, or I'm sorry, 8 tenths times 1,240 and 50 times x, and that ended up giving me 992, which I then have to divide by 50. And what is 992 divided by 50? Let's check on our calculator. 992 divided by 50 gives us 19.84. Now, I'm just curious here. What was our, what was that previous? Was that 24.8? No. 1240 divided by 50. 24.8 times 0.8. Do I get the same answer? Yes, I do. So our answer is going to weigh 19.84 kilograms, almost 20 kilograms for this number of cans. Is that it? I think that's it. How much time did that take us? Great, it's under 20 minutes. I would like for our lessons to be under 20 minutes. Sometimes it works out that way, sometimes it doesn't. Of course, this is action time, not paused time. It probably took you more than 20, probably close to 30 minutes to finish all this work, but not too bad for a day's math lesson. Go ahead and head over to the homework. This was the last lesson of the chapter, so we will be getting into study guides and chapter review before taking our chapter test in the next few days. So make sure that you show all your work and you understand what we're doing before we get to that test. All right, take care.
Hey, feeling good, like I should. When in dark, walk